So we are continuing on our lecture, our lesson on introduction to equations. And so the first part of this video, we had talked about adding and subtracting. Okay, and so this one is going to be um, multiplying or dividing. Okay, so remember the order of operations is important, but also doing the opposite operation when solving an equation, right? So if we are um, if we're adding, the opposite operation is going to be subtracting, and then vice versa. If we're subtracting, the opposite operation is addition. Same thing for multiplication and division, right? So if we're multiplying two numbers, okay, or two things, the opposite of that would be dividing, and then vice versa. If we're dividing it, then we want to multiply. Okay, so so in this case, for number one, we have 5x is equal to 15, right? So the operation that's happening between them is multiplication, right? Five next are being multiplied. So the opposite, what you want to do is division, right? So if I'm multiplying, the opposite operation is division. So I'm going to divide both sides by 5, okay? So x will give me 3, correct? All right, which a lot of you guys wrote down, which is great, okay? So then the cool thing about math is you can always figure out whether you get your answer is correct or not by plugging it in, right? So plugging it back into the original equation. So if I plugged in 3 in for x, 5 times 3 will give me 15. That's the beauty of math, okay? So most of the time you can just plug it in and see if your answer is correct or not, okay? Now, of course, the most important part as well is making sure that, I don't know why this is crossed out. This is supposed to be crossed out. Um, is the work is correct. Okay. It's one thing to get the answer correct, but is your process, what you did in that problem is correct. Okay. So that's more valuable than the answer. Okay. So the process, the way you got to that answer is the most important part. Okay. So that's number one. Okay. Number two, same thing, right? We got negative 7x equals 0. So we're going to divide, since it's being multiplied, so we divide both sides by negative 7. Okay. So a 0 divided by any number is going to give us 0. All right. Number three, I got negative 35 equals negative 5a. So again, we're going to try to get the variable by itself. So we divide both sides by negative 5. All right. Remember, two negatives, whether they're being multiplied or divided, it's going to produce a positive. So this is going to be 7. Okay. For number four, okay, same thing. Got negative 18 is equal to 3a. So we divide both sides by 3. Okay. So negative 18 divided by 3 is going to give us negative 6. All right. For number five. Number five, there's a couple ways of doing this. And, whatever works with your brain. Okay. So we got 1/2 x is equal to 3/2. Okay. So I'm going to show a couple of methods. Method one, we can do what we've been doing. Since these two things are being multiplied, I can divide them. So I can do 1/2 x divided by 1/2, and then 3/2 divided by 1/2. Okay. So um, I can do it that way. Okay. So then the 1/2 will cancel. And then we have 3/2 divided 1/2. Now I can do the keep flip switch thing, okay, which is perfectly fine. But I notice the 2 here in the denominator is the same thing as 2 here in this one. So that I can just cancel those out, right? So so I should get 3/1. All right. Or again, I can do 3/2 All right, and then I divide that, so I had to change it to multiplication and then flip it to 2 over 1. So the 2's will cancel, giving me 3 over 1, which is 3. Okay, this is probably the most tricky part for students. Okay, so, or again, I can do just take out the 2's here. These are both in the denominator. I can just take those guys out, and that'll just leave me 3 over 2. I'm sorry, 3 over 1, which is 3. Okay, so that's one way to do it. All right. Another way to do it is multiplying by the reciprocal. Okay. So um, let's do this method too. Okay. So the reciprocal. So again, we have 1/2 x is equal to 3/2. 1/2, the reciprocal of 1/2 is just 2 over 1. So I can multiply this by 2 over 1 on each side. Okay. And then the 2's will cancel. We got 1 over 1, which is 1. 1 times x is just x, right? Same thing here. These 2's will cancel. We get 3 over 1, which is equal to 3. Okay? So again, two different methods, and you can get the same result. In fact, I'm going to do one more method here. I just thought of, and that's by the LCD. Okay? Eventually, you want to start using method 3 when we get more into like rational equations. Okay? So I'll put method 3 here. Okay. Method 3 is, well, I got 1/2 x is equal to 3/2. So my LCD here is 2. Okay. That's the least common denominator. So I can just multiply both sides by 2. Okay. And then the 2's here will cancel because 1 times x is x, and then the 2's here will cancel, and I'm left with 3. Okay. So I would recommend, especially when I'm dealing with fractions, I recommend by multiplying by the LCD. That's my recommendation. But you do whatever you want to do at this time. But again, as things get more complicated, doing this route is probably going to be the best. Okay. All right. Let me pause here for a second. Okay, so here again, I can choose 3 different methods. In fact, I thought of another method, but I'm not gonna do that right now. But again, I'm gonna choose the method 3, which is the LCD. Okay, you can do whatever method you want that works with your brain, but I'm gonna just to kind of follow what I was talking about. So my LCD here in this case is going to be 10, correct? So I'm going to multiply this side by 10, and I'm going to multiply this side by 10. All right, so 10. So let me rewrite this. So I have 10 over 2, and then I have 2 times 10, which is 20 over 5 um, times z. Okay, so 10 over 2, that's going to give us 5. 20 divided by 5 is going to give us 4, right? So, and then I just divide both sides by 4. So z is going to give us 5/4. Okay. Now I can check my answer here. So if I were to check my answer, okay, so we had 1/2 is equal to 2/5 z. Z is 5/4. Okay. So the fives cancel, giving me 2 over 4, which reduces to 1/2. So again, I can check my answer and see that these guys are the same. Okay, so if we did method 1 again, so these two items here are being multiplied, so the opposite of that is going to be division. So I'm going to divide both sides by 2/5. So that cancels, giving me Z. But I have 1/2 divided by 2/5, right? So that means I keep the 1/2. I switch the division to multiplication and I flip this. So that would be 5/2. Okay. So
Wait,
then,
I'm
did I do
sorry.
something wrong?
I don't mean to interrupt. I just, okay.
Okay, so we had 1/2 equals 2/5 times Z. We divided both sides by 2/5, right? So we have 1/2, and this is being divided by 2/5. I'm just rewriting in this format because this is what we're used to. Okay, if you like this format, that's absolutely fine. Okay, so then remember, we keep the 1/2, the division becomes multiplication, and then this one we just flip it, 5/2. Okay, and then we multiply across. So that gives us 5/4, which is Z. Okay. Okay, so then for the last one here, number 7, right? We have 0.5 t equals 3.5. So we can just use our calculator there to make it simple for us. These are being multiplied, so the opposite is going to be division. So divide both sides by 0.5. Okay, so that gives us 7. Okay, so let's look at this problem. It says a furnace is turned on at midnight when the temperature inside the cabin is 0 degrees Fahrenheit. The cabin warms at a rate of 10 degrees per Fahrenheit per hour until 7 a.m. Make a table that shows the cabin temperature T in degrees Fahrenheit, X hours past midnight, ending at 7 a.m., right? So here's our table. We have on the first column, the time, okay, and then the second column is your temperature. So it tells us at midnight, right? It says at midnight, the temperature at the cabin is 0 degrees. Okay, so at midnight, which is basically 12 o'clock, 12 a.m., this was at 0 degrees. Okay, so 0 degrees. All right. And then it says that it warms at a rate of 10 degrees Fahrenheit per hour until 7 a.m. So this is just increasing 10 degrees every time. So at 1 o'clock, it's at 10 degrees Fahrenheit. All right, so I'll just put um, degrees in Fahrenheit. Okay. All right, so 2 a.m. that would be 20 degrees. 3 a.m. that'd be 30 degrees, so on and so forth, correct? Okay. So that's A, right? So this is what we have for A. Part B says, okay, we want to write an equation that calculates T, right? So in this case, the temperature, the output, right? Write the equation because T is talking about the temperature in degrees. So for B, okay, all right, equation. So we can notice that if I multiply 10 every time, so 10 times 1 is 10, or 10 times 0 is 0, 10 times 2 is 20, 10 times 3 is 30, so on and so forth. So that means our temperature equation is going to be T is equal to 10x, right? Because it tells us T is in degrees and X are the hours that pass midnight. Okay, so that will be our um, equation there. For C says, write your equation to calculate temperature at 5 a.m. This, um, Does the answer agree with the value in your table from part A? Yes, so basically we're going to plug in 5 in for X here, correct? So this would be T times 10 times 5, which gives us 50 degrees Fahrenheit. And that matches to what we have here in our table. Okay. All right, and the last part here is D, find the cabin temperature at 2:45 a.m. So basically we need to do part of that time. Um, so we're gonna have to take 45, all right, and divide it by 60, okay, because there's 60 minutes in an hour, right? So 1 hour is to 60 minutes, all right? So we just divide those two there, and 45 divided by 60 is going to give us 0.75, okay? Then we want to convert the 2:45 a.m., the 45 to 0.75 and leave the 2, so we have 2.75, okay? So 2:45 a.m. becomes 2.75. And then when we apply our formula here, we're going to plug in 2.75 for x. Okay, so 10 times 2.75. So that gives us 27.5 degrees Fahrenheit. Part. So another way to look at the 45 over 60 is we know that 45 minutes, we put that over 1 is the same thing as 45 minutes. We know that for every hour there's 60 minutes. So if I multiply 45 minutes times 1 hour over 60, the minutes will cancel, leaving me with hour because the time is an hour, every hour. But we don't have a whole hour, we got part of the hour. So that's why we needed to convert it um to hour because we only got part of the hour. So 45 over 60 will give us 0.75 when you put that in the calculator.